So next is we're gonna discuss, that is photoelectric effect. Photoelectric effect. So for photoelectric effect, what happens? See, this is a metal plate like this, and light is incidencing upon it. It is light. So what happens? This metal has a particular energy or work function. Okay, that is our E naught, or we can say W naught. If it exceeds that, then electrons come out of it like this. So these electrons must have a kinetic energy. So from this, Einstein deducted a formula, that is E equal to E naught plus K. Now this E is energy of radiation. Okay. Now we can write it like this, that K equal to, or E minus E naught, or from Planck's quantum theory we have known now. This comes like this, we can write it like this. So it has a form like this with respect to frequency. If you want to write it with respect to our wave, then it will come hc into 1 by lambda minus 1 by lambda naught. This equation has another form. If we have to write it, that is, this is separate, E equal to E naught plus half mv square, or h mu equal to h mu naught plus half mv square. So here our photoelectric effect is done. So now we have to see some graphs regarding it. So for the graphs, let's see. First, between K and frequency of incident light. So it will be it. Let's it E. It is mu. So the graph will be like this. It will be mu naught. And what will be the graph of K and intensity of incident light? Let's see that. K and intensity of incident light. So our energy is independent of intensity of incident light, so it will be a straight light. Okay. So here two graphs are done. So now we're gonna enter in atomic models. So first is our Rutherford's atomic model. Okay. So we're gonna learn it very simply because it doesn't come and also it is very simple. So what Rutherford said that in any every atom there is a positively charged central mass that is called nucleus. Now why this nucleus is positively charged? Because it has protons and neutrons. A proton has positive charge, neutron has neutral. So the result is this is positively charged nucleus. And he also said that from this nucleus to atom, this space is empty. Okay. In atom, the space is empty, only nucleus is present. And from nucleus to this periphery, this distance is very much. So how much? We can give an example that if this nucleus is a tennis ball and this periphery is situated from 5 kilometers from it. So you can guess how much distant or far away from nucleus is the periphery. So he also said that surrounding this nucleus, electron revolves. Okay, in a circular way. Now, this electron has some centrifugal force because it is revolving in a circular way, but it is balanced by the electrostatic force of this nucleus. Theory has some drawbacks. That is, Maxwell said that if any particle is moving, then charge particle, then it continuously emits energy. See, if it emits energy, then what will it become? It will be like this because its energy is decreasing continuously. So at last it will come to the nucleus and nucleus will collapse, but it doesn't happen. We see everything around us is made up of atom, but they don't collapse, right? So it is a drawback of Rutherford's atomic model. So this model is discarded. So we're gonna discuss about a model which comes very often, that is our Bohr's atomic model. So for Bohr's atomic model, we're gonna discuss first is postulates. That is Bohr said around the nucleus in circular ways, electron revolves like this. Okay, so only this circular way electron can revolve. So these are called orbits. Now they are revolving in a circular way, so they must have some angular momentum. He said this angular momentum's value is nh by 2 pi. Now in second postulate he said this electron can neither emit energy nor absorb any energy. Okay. Now here comes the third and most important postulate, that if a electron, okay, goes from higher state to lower state, that means it is moving in outside orbital, but it wants to come in this orbital. So what it has to do? It has to emit energy. Okay, and if it has to go outside, of the outside orbital, like this electron wants to go in this orbital, so it has to absorb energy. Okay, so in the third postulate he said that if an electron wants to go from higher state to lower energy state, so it has to emit energy. Or if it wants to go from lower energy state to higher energy state, it has to absorb energy. So we have to see some formulas regarding it. First formula is regarding to energy. That is, what is the energy required to go from a higher energy state to lower energy state or vice versa. Okay. So the formula comes it like this: z square by n square. Now we're not gonna discuss about the derivations because it doesn't come in it. So if the values are given, you can just conclude it, but it is not that simple. Okay, we have to know that this energy is directly proportional to z square by n square. Now they will ask you that if an electron goes from n1 equal to 1 to n2 equal to 2, what will be the energy variation? Now how can we deduct that? Let's suppose the previous energy, that is E1, was z square by 1, because it has said that n1 equal to 1 and it is of the same atom, so z is not changing, right? So what will be the E2? E2 is said z square by 4. So we can easily write it from the previous equation because E1 has come z, so we can write it like this. So E2 equal be E1 by 4. Now if z is changed, so what we will do? If z is changed, what we will do now? Let's, from H it has gone to helium. Matlab, from hydrogen it has gone to helium. So now E1, and let it also be constant, that from N1 to it has gone to it N2, and also Z is also changed. So what will be the E1? So E1 will be, because hydrogen's atomic number is 1, so E1 equal be 1. What will be E2? E2 will be our, if Z2 is given, that means 2, it will be 4 by 4, so it will be also 1. So here E1 comes equal to E2. That means from hydrogen to helium, if it is goes from N1 to N2, so the energy will be the same. So it often comes. So now we are gonna discuss about radius. Okay. So what is the formula of radius? That is 52.9 into n square by z picometer. Now you see that radius is also directly proportional to n square by z. Now, like the previous equation, we can also conclude the variations from this proportionality. So here our Bohr's equation is done. Now we'll discuss about line spectra of hydrogen. Okay, line spectra of hydrogen. Now what is line spectra of hydrogen? That is, that in a discharge tube some hydrogen gas is present. Okay, Now, here a electrical discharge is given. So what happens? This hydrogen gas becomes ionized and it emits electromagnetic radiation. Okay. Now, Balmer first saw that this has a value around 1 by 2 square by 1 by n square. That is r into 1 by 4 minus 1 by n square. Now, later this equation is modified and written as 1 by lambda or wave number equal to r by 1 by n1 square by 1 by n2 square. Now, many series come from this, and we have to also know the value of r. So, first write the equation once again. So, mu equal to, that is wave number, equal to 1 r into 1 by n1 square by 1 by n2 square. This r is called Rydberg's constant. And its value is approximately 109677 into 1 by n1 square by 1 by n2 square. Now, if this n1 comes 1 and n2 can anything from 2 to 4, 5, 6, 7. So this series will be called Lyman series. Okay. These series are spectral series of hydrogen. So if n2 equal to 2 and n1 equal to 2, if n1 equal to 2 and n2 equal to anything from 3, 4, 5. So this comes our Balmer series. It is our visible spectrum. Okay. Now, if it comes n1 equal to 3 and n2 equal to 4, 5, 6, then it comes Bastian series. And if n1 equal to 4, n2 equal to 5, 6, then it is called bracket series. And if it is n1 equal to 5, n2 equal to 6 or 7, then it is called p-fund series. Or if n1 equal to 6 and n2 equal to 7, so then it is called Humphrey series. Okay. So normally only up to Bastian series it comes. This 3 doesn't come, so don't stress out. Now we have to discuss about de Broglie wavelength. Now what is de Broglie wavelength? We have to know first what de Broglie said. Okay. De Broglie said that if a moving charge particle or electron it has two natures. One is wave nature, one is particle nature. So it has both. So from this, we seen Planck's on equation E equal to h mu, and we also know here E can be written as mc square, because from Einstein's equation we know equal to mc square. So H can be written as hc by lambda, because mu is equal to velocity by wavelength. So what happens? This equation comes here. De Broglie modified it, written it like this. So it is our de Broglie's wavelength. Okay. Now this equation can also be modified. That is half mv square if we equal to k. Okay. Now we know that momentum can be written as like this with respect to our energy. So this equation will be modified like this: h by root over up to m. Okay. So here de Broglie wavelength is done.
To learn difficult concept of physics, chemistry and biology within few minutes to crack NEET and JEE with fun, like, share and subscribe our new YouTube channel ShantU. You will get conceptual videos, highly effective notes, short tricks, mock tests and much more. Hope we shall meet there.